Today is May 16th, 2018. My name is Avron Barr. I'm conducting an oral history of Bradley Allen. This is part of the ongoing oral history program of the Software Industries Special Interest Group, which is part of the Computer History Museum in Mountain View, California. We're here at the Computer History Museum today, and this interview is being videoed and recorded and will be transcribed, edited, and posted on the Computer History Museum website. Let's get started.
All right.
Brad, tell us a little bit about your life today. Where are you, what are you doing, and what's life like?
I am currently chief architect at Elsevier, which is a publisher of scientific and medical information. I'm living in Los Angeles and Manhattan Beach, California, to be specific, and really enjoying being part of a company that's really trying to push forward what we're trying to accomplish with science and medicine, and sort of make the world a better place. And working as a chief architect, which means that you end up having to do a lot of things, covering a lot of different topic areas and challenges, and so it's a good life right now.
Good, glad to hear that. Anyway, I'm going to take you to Elsevier later, but I want to go all the way back and see how you got here.
Sure.
So where'd you start out?
I grew up in the Northeast of the United States, a number of different places we lived: Pennsylvania, New York, Ohio. Went to high school outside of Philadelphia, and started my career sort of as a computer programmer, if you want to put it that way, back when I was 14. Some folks who were at the Burroughs Corporation, which at that time had a significant presence in Paoli, Pennsylvania, had a explorer troop that they convened to bring people in, kids, and introduce them to computing technology. Started working on some of the old Burroughs equipment, and then at the high school we had access to some time-sharing machines, and so just started programming and really loved it and wanted to basically go in that direction as a career.
So you had a lot of exposure to programming in high school.
Yes, and it was it was very early days, but it was a good opportunity to really get into it. And I had been exposed to some of the concepts and really fascinated by some of the history of logic, the original sort of work by people like Turing and Gödel and so forth, and just kind of captured by the idea of symbolic logic, which is
even back then, even in high school.
Yes, and so
did you have courses in high school?
No, not so much. But there was a math teacher at the school who had access to the time sharing system that we were able to work with, and so there was exposure there for sure.
Was it just computing, or did you have other interests, academic kind of interests back then?
No, I was interested in general in history and science and a lot of those kinds of sort of areas, just generally curious. But computing is the thing that really captured my interest. And there was a moment back in high school when I encountered a kind of a pivotal document for me, which was Stuart Brand's Two Cybernetic Frontiers. I remember very clearly going to a bookstore in King of Prussia and buying that book, and it had, the first half of it was a portrait of Gregory Bateson, the cyberneticist, but the second half was the article that Stuart Brand wrote for Rolling Stone on life at Xerox PARC and at the Stanford AI Lab, and that was just, that was a picture of everything that I wanted to go and do. And in the back of that article, in that book, Stuart Brand makes the mention about, where do you go to college for, computer science? And in there it says the best place to go is Carnegie Mellon. So,
and that was it. That's why you went.
That's why I went, and that's why I ended up in Pittsburgh at CMU.
So when was that you went to?
That was '76. It was my first semester there.
What did you study and why?
Well, at the time, the computer science department there was a graduate program only. And those of us who stumbled into CMU looking to become computer programmers at the time ended up in the applied math program. There was a applied math with computer science specialization, and That's sort of that was the track that they had at the time, and it was pretty phenomenal in that, at that point in time, it was just a tremendous group of people there. It was a sort of a jumping off point for a lot of things, including the stuff we'll be getting into later. And the undergraduate people, of which I was, one, had a great deal of exposure to what was going on with the graduate courses. It was very easy to kind of get involved with, a lot of the courses that were being taught to the folks who were coming into the PhD program. And it was just a wonderful environment to be at. Really just kind of focused on that one in the time that I was there.
So your degree was in applied math, but you were exposed to a lot of computer science courses too?
Yes.
As well as projects.
Exactly.
It does sound like a good environment. So what was life like at CMU? What kind of things were you doing in terms of studies and coding and life?
Well, CMU is a place that is one where you do best if you know exactly what it is you're trying to achieve. At least it had that kind of flavor at the time. It's very, very, intense, focused work that you drove yourself as hard as you could to be able to kind of deliver, in that sort of environment. But at the same time, it was a blast because we were getting exposed to things that, there were very, very few places at that time, even among the elite universities, where you could get, access, for example, to Alto machines, to some of the very early, DEC equipment that, became so pivotal later on, and so it was a lot of fun because it was a very challenging environment, but at the same time, just a bunch of people just kind of, sort of spreading their wings and looking for, things that they can make a contribution in.
It was a very interesting time, and I'm wondering if you think back, if there were particular people that were especially influential during your years there.
The folks that were engaged in trying to understand where to go with artificial intelligence applications were kind of first and foremost for me, because of what how I got involved was through Jaime Carbonell's Introduction to AI course, and Jaime taught that, and at the end of that course there was an opportunity, for example, and they gave opportunities. Says, here's a project that we'd like people from the class to work on that is involved with some of the research that's being engaged on, and Mark Fox was one of the he was a graduate student at the time, but very rapidly getting involved in the commercial exploitation of artificial intelligence. He had a project that he suggested that I went and contributed to and became involved with, and then that led to the work with Mark at the Intelligent Systems Laboratory. So Mark, Jaime, other people in that environment like John McDermott, who were involved in sort of the early blush of expert systems, were really important, people that I engaged with there at the time. And there were the people who were just there that you could interact with. John Bentley, took a combinatorics course from him, and that was in the beginning of, a lot of the stuff that he was doing in terms of just sort of, the stuff he later put into to publications like Programming Pearls and the like. He was a fascinating teacher. There was a great class. Peter Andrews, who was who taught logic and worked very heavily on higher order logics and their automation, took a number of courses there. Gerald Pottinger, who was in the philosophy department actually, as a logician, was somebody I spent a lot of time with. That harkening back to sort of that early interest in logic and automated reasoning. Those are people who really had an impact and influence on me at the time.
So you mentioned Mark's project that you got involved in. This was, you were a programmer on the project?
Yes.
So what was the project about?
The project was, we did a number of things in Mark's lab, but the most significant one at the time was a project for Westinghouse, planning, production and manufacturing of turbine machines. And so it was a lot of the sort of stuff that he and Monty Zwiebin, for example, got into, significantly as time went on, around how do you improve the state of job shop scheduling? How do you make it more efficient? How do you make it not optimal, but deal with the complexity of the task by applying heuristics and notions of, search through, a state space that you could define, based on the constraints associated with the job shop floor. And so, working on those kinds of programs, some things around, simulation of job shops and the like. And this was around the time of the founding of the Robotics Institute, which Mark's Intelligent Systems Lab was part of. And so we were all kind of engaged with projects that demonstrated the application of artificial intelligence to those kinds of industrial problems. Westinghouse being a founding sponsor of the Robotics Institute, that was a big source of the kinds of problems that we were tackling and the areas that we were getting into.
Remember anything about what tools you were using? There weren't any tools back then, so what were you programming in? What was that like?
We were using Lisp, and if I'm not mistaken, it was Franz Lisp or an earlier version, in that vein of development on VAX 11780s primarily. So it was, which was a great environment, and one that was a tremendous amount of fun as well, because we were sort of, we were sitting there on, one of the main CMU ARPANET nodes at the time, and we had our bulletin boards up on Usenet, and internally we had access to a lot of really interesting and innovative software at the time that was just internal to CMU, but you could see ripple through later days. The Zognet, which was Alan Newell's attempt to kind of build an early form of hypertext. The usual kinds of Unix entertainment sort of things that were up there. So we were programming away in Franz on 11780s, and later got into using the perks, but it was primarily DEC equipment at the time, with Lisp as the main programming environment.
You were probably one of the first groups that had access to the internet as a tool for your research and for your lives. Can you remember whether that was influential, the fact that you could connect in an instant with anybody else doing research in AI?
Yeah, there weren't a lot of people in general kind of to deal with. I mean, it made a huge impact on our ability to talk within that community, and primarily within the CMU community. It wasn't so much the kind of thing we do today, where I'm on a social network and interacting with people globally with very, very little effort. Right? It still took an effort to kind of reach out. It was still more of a personal relationship thing to be dealing with people at Berkeley or at ISI, at USC, and so forth. I mean, but we used email very fluently, and ran into a lot of the things that have challenged people ever since. In terms of etiquette, I remember very clearly reading the threads where Scott Fahlman initially proposed the use of what ultimately has become emoji. The whole thing where people got bent out of shape at each other over a misunderstanding expressed on a bulletin board, and Scott came on and said, what, we need a thing that allows us to tell people when you're kidding, and so here's this thing with a colon and a dash and a parenthesis, and so it was very early days, but that kind of way to communicate and get information across back and forth was something we felt that we moved into very naturally, and is completely consistent with the experience that we have today. So it was a very early look at that. That was back, say, 78. And there were not a lot of people who were interacting with email and each other over email in that way.
How long were you at CMU?
7 years all told, from in the door to leaving for California. And a lot of that time, when I joined Mark's lab, I became an employee of the university, and that was a tremendous thing. at the time because, that took the pressure off of tuition. You kind of pace yourself. Living in Pittsburgh at the time was very economical. It was a great life, and it was hard to leave because it was such an amazing environment at the time. But I was there from all told, calendar-wise, and my time as an undergraduate and time as an employee of robotics, it was 7 years.
Did you graduate before you started?
No, I started working, I think, as a sophomore in the second semester of my sophomore year, as an employee of the university, and that was great. Getting paid, and getting a degree,
having
and
real
working
work to
in
do
this
as
incredible
well as
place.
I can see that sounds really good. Was it a natural transition where other students sort of following the same path?
Yes, I mean there were a lot of folks that kind of took that path where they weren't in the graduate program, they were undergraduates, but they showed ability. And at the time, a lot of and still to this day, a lot of money flowed into that environment that created a demand for people who could take on the programming task, who weren't otherwise engaged in either getting a PhD or teaching classes or being a professor. So, and there are people who are there to this day who have basically risen in the the CMU organization to positions of responsibility, who I knew there as an undergraduate. We were all undergraduates working at the time.
Looking back, what do you think was, what do you remember about the work you did at the Robotics Institute, and how did that influence you?
A lot of it was focused on trying to take these very hard practical problems in industry and take this technology, which allowed us to express information symbolically, to be able to reason about that, to be able to apply search algorithms to come up with solutions that satisfied a number of constraints. Kind of assembling all of those things, but delivering them in an industrial environment was a key aspect of what it was we were trying to achieve there at Robotics. So it was different then. There was a lot of theory going on at the time. Dana Scott was there at the time, an example of that kind of level of work. Alan Newell and Herb Simon were still active. A lot of work on operating systems and so forth. But the work that we were engaged in was how do you get, what came to be called expert systems technology in a position to be able to deliver value in an enterprise environment. And that was that was that was my first exposure, certainly, to the challenges engaging that you engage with when you actually try to deal with it. How do you integrate with existing systems? What are the organizational dynamics that either enhance or frustrate technology transfer and adoption? It was all an exposure to those sorts of things, very early on.
When you came to CMU, had you had a focus on AI? Was that already in your mind as a place you wanted to go, or a possibility?
Well, the thing that I had kind of walked in there with was this very romantic notion of the power of logic, and the tradition, which I still gather. I still gain a lot of strength from, if that's the right term for it, of this path from the early 20th century, the time around 1930, the golden era of mathematical logic, and that notion of automated reasoning being brought forward to be able to create, if you want to call them thinking machines, that using that sort of terminology of the time. That was the romance of that was the thing that I was really interested in. In fact, I remember Simon and Newell's general problem-solving book is something that I got before I actually came to Pittsburgh to go through and understand and kind
Really?
of, yeah. Now, I can't say that I necessarily understood every nuance of that, but that was the sort of thing that I had in mind that, that attracted me to that environment.
Who did you work with most closely at the Robotics Institute?
Well, with Mark, certainly, Jaime Carbonell, and and folks who were working with him on some very early kinds of natural language processing tools that came into play. Where we physically worked, we were co-located with a number of folks on the robotics end, Hans Moravec and his lab, David Bourne, and we ran into a lot of folks in the hallway, kind of worrying about making robots move around without hitting things and that sort of stuff. Very early days on that, because that's about 82 to 84. There are a lot of folks, from there. Jim Crowley, I believe, if I'm not mispronouncing his name. He was working on robotics problems at the time. I have a very clear recollection of Mark Rabert's earliest work on locomotion. Every day I would go down, and what at the time was called Ween Hall, is now Newell Simon Hall, if I'm not mistaken. And he had his leg lab. So sitting in the middle of this concrete, cinder block room was this mechanical pogo stick hanging from the ceiling that would jump up and down. And if you look at the videos now that Boston Dynamics, for example, shows of the things that they're building, and there's a direct lineage from that leg lab and that work that Mark was doing to the kinds of amazing stuff that those folks are doing today. So those were the people in the environment at Robotics.
As you look back, this was your extended undergraduate career.
Yes.
It was unusual, I think, in the degree to which you were involved in research, and especially programming. Did that work? I mean, do you think that was unusual, and did that work as a way to get involved in artificial intelligence?
Well, I mean, it worked for me brilliantly. And there were other folks that were there with me at the time, Mark Wright, Gary Strom, Paul Haley, who, all of whom I subsequently did a fair amount of work with in the expert systems days. We all kind of came along that progression. And I mean, it was a tremendous introduction to real problems at the bleeding edge in an environment that was extremely supportive. Not competitive or judgmental in a way that some organizations are. It was just, we're all in here trying to figure out how to use this cool stuff to do cool things. And I see a lot of antecedent in that to some of the things people are trying to accomplish now with, getting younger folks to become coders and be introduced to computers and so forth. And it was just it was a very natural thing. I think it was an alignment of purposes. The folks who had raised money to fund research needed people to actually implement things, and those of us who were implementing them got a great deal of value out of that.
There was a lot of stuff going on in AI at other places at that time, partly because of the internet and email, and partly because of just going to conferences together. There was a lot of cross-seeding of things.
Yes.
As you look back to those years at CMU, what was really influential? What were the highlights of the intellectual progress during your years there?
The realization that there were, that people were beginning to build systems that actually touched real world problems. Okay, the beginning, to spill out into practical applications was a big thing, right? Up until that point, we were working, or people were working on kind of toy world problems or games. I mean, one thing, in that environment, a lot was going on with work that continues to this day on solving, or not solving in the true technical sense, but getting computers to play effective games like Othello. Paul Rosenblum did that work at the time that I was around CMU. Hans Berliner was there, but those are all kinds of interesting AI challenge problems the breakthrough into, really actually being able to build things and deliver them to business was pretty impactful, at least from, the perspective that I had. And there was a lot of excitement in and around that. A lot of that was, generated by, things that were goals and initiatives driven out of, the federal government or the military to kind of, get to this vision of, autonomous systems that were able to work in, a variety of challenging environments. And that, created a lot of work in places like MIT and out here in the West Coast, where you were building environments to work in that sort of way, which is, kind of the birth of the Lisp machine and Lisp as an industrial kind of programming environment. So a lot of that was kind of going on. So that whole issue of we're about to take this stuff out of the laboratory and bring it into practical use was a big thing at the time.
Yeah, shaped a lot of what went on. Do you have a favorite project from that period, or something that you particularly want to?
Well, I think working on the system that Mark particularly pioneered, the ISIS system, which was intelligent. I forget the acronym exactly, but it was the scheduling system that really brought forward some concepts that were pioneered originally in some of the speech understanding systems. Things like beam search as an algorithm, and looking for ways to be able to make it easy to come up with a satisficing solution for a job shop scheduling problem by applying that kind of a technique. Going in and implementing that system, building some of the visualization of the exploration of the state space and some very primitive kinds of graphics capabilities that we had at the time. That was the project that really sort of crystallized, not only for Mark, where he was going in terms of his research, but again, this notion of we can build some really sophisticated and useful systems for industry. I particularly enjoyed my contribution to that project.
Well, I have one more question about CMU, and it's more or less about the academic path that you took there. So you were in applied math as a department, but clearly you were exposed to the computer science curriculum and the AI curriculum.
Yeah.
Anything stand out there as particularly good or particularly problematic in the way that you came into the field?
Well, it's funny because the mathematics department, who at the time was headed by George Moore, was really focused on problems around differential equations and that sort of thing. So it was a bunch of old diff EQ guys who really were not annoyed necessarily, but the idea of having to deal with a horde of aspiring hackers was not exactly what they were kind of focused on, right? But that really didn't turn into any kind of barrier and impediment. The people who wanted to gain access to what was happening in the computer science part of the curriculum had no problem doing so, because as a natural part of the track, we were meeting the professors, we were meeting the TAs at the time, and people like Rich Korf, now it's at UCLA, was my TA for the Introduction to Software Engineering course, which at the time was taught by Elaine Kant and Guy Steele. I mean, just tremendous folks, right? And so very quickly, because of that track, you got that kind of exposure. And if you had any sort of desire to get involved at all, you were welcomed into that environment. I ended up taking something on the order of 9 semesters of logic, okay, including 4, graduate seminar kinds of things, where I was given the opportunity to explore a wide raft of different topics and work on things like decidability problems and the like, and had an opportunity to present in graduate seminars, sort of this, summarizing some of the recent results in that area. And there's somebody I should mention who I guess, and I regret not having brought him up earlier, but was just a tremendously impactful for me in that time. was a gentleman by the name of Garrett Burkhoff, who was an incredible mathematician, son of Garrett Burkhoff himself, who was one of the leading lights of mathematics in early 20th century America, buddy of John von Neumann. And at the time he was kind of semi-retired, but he was teaching at CMU a course in abstract algebra. And, having the opportunity to engage with people like that and with that kind of history. And he was tremendously supportive of, just the interest in the work. It was a great environment. And so, there was really no impediment to somebody who was motivated to go out and gain that knowledge. You were there in an environment where you could get it.
So that leads to the next question. Why'd you leave?
It was time. I think the other thing to be said about my undergraduate career was I was not necessarily the best of students from a traditional kind of perspective. I mean, I gained a lot out of it, but and it wasn't clear that there was a real graduate school path for me at that time. So after I had been there for a number of years at Robotics, it was clearly time to kind of figure out what the next step would be. And that happened in '83, just about the time that the real venture interest in expert systems companies began to blossom. And so, the opportunity presented itself really based on the fact that a lot of money was starting to go into that sector. Some of the first wave of expert system companies started to happen, and they needed people who were knowledge engineers. And there were outside of, the communities at Stanford, to some extent, a little bit at MIT, there were no people who could look people in the eye and say, yeah, I've built that kind of, expert system for industrial application. They couldn't really say that, but I could, and some of the folks that I worked with at CMU could as well. And so all of a sudden, an opportunity presented itself in the context of that, the emergence of the first generation of expert systems companies. So that became a thing. And
so what did it look like as you were ready to leave and you looked around at did you look around at possible places to go, or did somebody come and get you?
We were headhunted, but at the same time we were thinking, myself, Mark Wright, Paul Haley, a number of others in the environment at CMU had been thinking about what would it take to start a company? What would a company look like? I mean, we had serious discussions about, could you build a company around a language? What would that look like? And so forth. And we had a number of conversations with people like Rick Hayes Roth when he came through, and just sort of exploring that idea. So, I mean, if in the absence of that kind of external, people looking for people to come join them sort of thing, we probably would have ended up doing something on our own in that vein. But, people came calling who had just raised rounds and gotten into, we're going to build out the companies that are going to solve this problem for industry. And we kind of, that was an easy way to get started into it.
Now, one of those early ventures was at CMU.
Yes.
Carnegie Group.
Yes.
Was that after you left, or was that something you considered and decided to
I considered it. I got an offer from, very clearly I remember the letter from John McDermott. I said I would come, and then within the week,
really,
I got an offer I couldn't refuse from Inference Corporation. So, not something I'm necessarily terribly proud of, and that Mark Vox has, mentioned that he's still mad at me about. But I, knew everybody who was involved in, the initial work on founding and getting Carnegie Group off the ground. I remember very clearly the conversations associated with that, while Mark was, and the rest of those folks were trying to form that. And so, that was tempting. But, at that time I had been 7 years in Pittsburgh, and, the West Coast beckoned for all sorts of different reasons.
Do you mind if I ask you what some of those reasons were?
Sure. I mean, one is the very kind of, simple attraction of, being in California. It's kind of, it's laughable and naive to think about it. But at one point in time, while I was at CMU, Tim Leary came through, and was doing his stand-up philosopher thing at the time, and he gave a talk, and like part of that talk said something to the effect that, Western civilization is going faster and faster in a westward direction, and it's just going to hit the California coast and go into space. And that kind of stuck with me, right? It's like, I really maybe want to end up in California. And I had an opportunity to come out and visit a couple of times. I mean, Mark Fox and I came out to a workshop on agents that USC-ISI ran out in Idlewild. It was my first introduction to Los Angeles, and it was just an amazing, beautiful place. It was very attractive from that point of view. I remember coming out and interviewing for Inference Corporation and ending up at LAX and walking out from having just gotten off a plane from a very dreary and kind of like snowy Pittsburgh, and there it was, the clear blue California sky. So there was that. I had family who had recently located to Los Angeles, and that was part of it. But it was a sense of adventure and California being a place to go. And there were a lot of folks from a lot of people that I knew who had gone to ISI as part of a very close relationship, I think, that had been engendered between CMU and ISI at the time. And so there were people out here saying, "Come on in, the water's fine." It was a very natural step from that perspective.
The computer science community was still pretty small then, so everybody knew everybody pretty much.
Yeah, and it was an interesting environment here in Los Angeles because there were pockets of there were the folks at USC-ISI who had that was a great thing at the time. Bob Balzer was the lead guy there, and he had collected quite an interesting group of people, and they were a really significant cornerstone of what happened with the emergence of the internet and so forth. So there was that there in LA, and there were some folks doing work at the main campus at USC and UCLA. Not much in a commercial environment. There's a scattering of tech companies, but as you were referring essentially to the computer science community as a whole, right? I mean, we're all just basically a few scattered nodes on the original ARPANET, and people knew each other.
So when you got to Inference, what was there, and what did you start working on, and why?
Well, it was an interesting environment. I mean, Chuck Williams and Alex Jacobson had been working for a number of years already.
Really?
Yeah. I mean, Alex came out of Hughes Research, and Chuck was out of the USC-ISI group, and they had hooked up to build a natural language understanding system. And Chuck was building that on top of Lisp, and one of the challenges they had was we need an environment to make this run fast and be a thing that will really work beautifully and deploy. And they managed to get involved in the original founding of Lisp Machines Inc. With Rich Greenblatt, and were engaged in the whole kind of series of events that happened between LMI and Symbolics at the time. They also did some work with Steve Wolfram on a very early version of what ultimately became Mathematica, which at the time was called SMP. So they had been working for a number of years, I think starting in '78. And Alex had managed to attract an investment from Venrock, partner Tony Sun at the time, and as part of the sort of this initial set of investments that the VC community made in artificial intelligence companies. So Chuck, who had been really kind of wrangling this by himself and a few others, was in a position where he needed to move quickly in terms of getting people. And it was a struggle because Los Angeles was not Palo Alto. It was not near any of the traditional AI centers. Chuck was working with a headhunter at the time, and Chuck was just working himself to death. and got very, kind of, sick and run down, and was on the phone emoting to this headhunter about, just not getting any traction and so forth. And the headhunter said, well, just give them, just give them offers they can't refuse. And that was the thing that, just basically hooked me to come out and start with them. And when I got to Inference, there was the work that Chuck had done on the LMI machines. And he had built a system, which, ultimately was the system that became ART, which had some really interesting and innovative elements, principally around what in the subsequent years came to be known as assumption-based truth maintenance, but really the ability to have a way to be able to manage sets of assertions and reason in those sets of assertions independently, so that you could build a way of doing hypothetical reasoning in a very structured and disciplined way. It was brilliant work, and it was very efficient and fast, and it was Chuck's baby, and he had a lot personally invested in that. When I came from CMU, I mean, the way that I came and the kind of way that I showed up, attracted a lot of interest from some of the other folks that were there, Mark Wright and Paul Haley, and I said, this is a great opportunity, and so they came out in short order. And we came there from CMU with a perspective that was born out of the digital equipment work on XCon using production systems, the work that we had been doing in Mark Fox's lab, which was very much in this production systems model of building rule-based reasoners. And a lot of the focus was on speed and the ability to do that. Some of the work that Mark Wright and I had done very early on in the 82, 83 time frame on hybridizing rule-based systems and what we called schema systems, which were essentially frame-based or object-based knowledge representation systems. We brought all that out there and worked with Chuck to kind of mold that together into a cohesive whole of, it's essentially this big toolkit of things that you could apply to a problem to see if you could make some progress on that. We showed up in the spring of '84. I got there in February '84. I think Mark and Paul ended up there a few months later. And the goal was to build something that we could demonstrate at the AAAI conference in Austin in August.
In August, wow.
So we ended up, doing the classic, eating and sleeping in the office thing for, that period of time, and just moved heaven and earth to build what we demonstrated in Texas as, ART, the automated reasoning tool. And we brought a lot of ideas together and worked very, very quickly in a collaborative way to sort of synthesize this whole, and it was an interesting time.
So how many of you were there besides the four you've mentioned? Was it a big group or a small group? And
there were maybe about a dozen people all told. Some of whom, were there before we showed up. A couple of folks, from that era. Rich Schrappel, who is, I believe, currently at University of Arizona. He was there and was an amazing guy to work with because of his just incredible ability as a mathematician, particularly, as it related to encryption and, he was a co-author on the MIT Hackman document. We had another fellow from Aerospace Corporation who joined us, Charles Calmy, who his claim to fame in our world was he was the last American to defeat Bobby Fischer in a game of chess. So it was there was a whole range of individuals there that were really very, very talented. But we were all told about 12, 15 people. The core group was Chuck, who was dealing with the truth maintenance system, Paul, who implemented the rule system, Mark, who implemented the schema system, and I did my best on the interactive development environment that was part of the shell, and that was the team.
As you recall, from Inference, looking around at this AI world that was just developing, this commercial AI one, what struck you? What were you thinking as you looked at your competitors and at the marketplace about how Inference would proceed?
Well, the thing about Inference was, and I think through its existence until it kind of found its niche in the 90s, was we always had a chip on our shoulder because we weren't one of the companies out of Stanford or so forth, right? So there was this competitive kind of feeling. It's like we can we're gonna show those guys up at Stanford what we can do, and I think that was there was a mutual feeling of competitiveness amongst all those different companies, and so it was an environment where once we released art, the demand from the federal government or people who were being financed by the federal government for this software was enormous. I mean, and it was of the order of, we're going to buy every version of everything that we can get our hands on just to figure out what to do with it and how it works, right? So it's just this tremendous early adopter kind of demand. And so, we released this stuff, in August, or launched it. It's probably the better way to say it. And immediately we were doing about $1 million a month in revenue, just on the basis of selling this, selling training associated with it, starting to do some of the early expert system projects, under the aegis of Inference and so forth. And that, experience was being recapitulated pretty much everywhere amongst those early companies. And so there was this feeling of, wow, there's something here, and we're riding a wave, and just tremendous excitement associated with that.
Somebody once described that wave as every Fortune 500 R&D lab buying one of everything.
Yes, right, and so that was a signal from the marketplace that I think, certainly in retrospect, we took the wrong way.
We all did.
But it lasted for a while. It lasted long enough for us to garner a significant investment from Ford. It led to some real growth in the company, and it led to a lot of really interesting projects. The early work we did with NASA Johnson Space Center, the work we did with American Express and the Authorizer's Assistant. I mean, these were significant systems that we were able to build in the subsequent 2 years, the period between '84 and '86. Were some of the first successes that the expert systems people could claim in systems that were really automating decision making in one way or another, and that was being recapitulated across the industry. The other thing too, I think, is that's worth noting is there was a lot of people were trying to differentiate on the basis of features of languages and tool capabilities that were pretty arcane, okay, and certainly in hindsight. But at the time, we thought, you can't really be serious unless you have this particular kind of feature, or here's a new way of doing stuff that just is simply not achievable in this other sort of way. And so, there was a lot of these systems brought together a whole mass of different techniques, some of which were well integrated and some of which were not. And they were presented in kind of this jumble, and it was really left up to the people who were implementing the systems to sort of pick and choose what was effective and what was not. And so that process of discovery about what was really material in terms of really achieving results was kind of mixed into that whole thing. And as people piled into the industry, to take advantage of the market that had appeared, there was a lot of confusion about what you really needed, and a lot of different ways of talking about and architecting systems that created a lot of confusion and sort of ideological rigidity in terms of how people position themselves. Their production system people, or their model-based reasoning people later on, and the like. And And they were all differences that, in the long run really weren't necessarily as meaningful as people thought they would be.
Did you see, as you looked at the competitors, did you think that art in particular was an advantage? Art was sort of your ticket, your product to
Sure.
enter in here. So I'm just trying to get a feeling for how that went for you.
Well, I think, we made a lot of the fact that we had taken a lot of the ideas on the efficient implementation of production-based or rule-based systems and build a nice implementation of that. So part of what we were saying is that this is you can reason quickly in a forward-chaining direction. Mm-hmm. Part of it was, the ability to reason hypothetically that came from Chuck's work, which was pretty unique. None of the other expert system shells really did that, and that was a big differentiator for us. There were a bunch of other features that you could add into that, but those are the two that really were sort of the hallmarks of what we would position as advantages when we went in to compete against people like IntelliCorp and technology and the like. I think in hindsight, and as I know from speaking with Doug Lennett, he would say there was a lot of really sweet technology that turned out not necessarily to be either easy to use or, again, something that made a difference in terms of people's ability to implement actual applications. But that's what we had in mind, is we had a really fast rule engine, and we had the ability to do hypothetical reasoning.
I gather you were involved both in designing and building art and in the applications of it.
Yes.
Some of the applications anyway. So thinking back, what strikes you as the most interesting work that you did as in the application side?
Well, for the first year and a half there, I was pretty tied up with the tool itself. And there were others that we brought into the environment. Mark Malitz, who worked on the first system we did for NASA. Laurent Piketty, who was involved with the authorizer system, American Express. And we kind of built out those folks, brought them in, and they're the ones who really kind of were the feet on the ground making the expert system stuff happen. I came in later as kind of the other folks took over the evolution of the tool, did some work with NASA on building systems to help manage software libraries and do software parts composition and things like that. Did some work for DARPA-funded projects on expert systems for detection and recognition of test ban treaty violations and things like that. So there's a smattering of a lot of different kinds of simple expert systems work. But a lot of what stood out for me were those first initial systems, just kind of the satisfaction of having engaged with organizations like NASA and American Express or American Airlines and built these things out and delivered them, and working with the teams to support them, because the tool itself was something that was more or less used as is, but a lot of the challenges that we had with those systems were really around integration, right? I mean, American Express, we had to get that system, which was at the time running on symbolics machines, integrated with the mainframe-based systems that their authorizers were using to be able to make credit decisions. And so, I mean, there was a lot of, baling wire and chewing gum kind of, and serial ports involved to kind of make that work. And just sort of being there and supporting those guys was a big part of what we were doing as a central team.
So, as the years went on, things changed. Inference changed, and art changed, and the marketplace changed. What do you think was as you look back from those early years of everybody needed AI, and there were just a plethora of projects to choose from? How did that change over the subsequent 5 or 7 years?
Part of it was, I think, an evolution of what was, I mean, the acceptable set of techniques and tools that you really needed to build an expert system. I mean, the things that we built were very expensive, and they ran on really expensive hardware at the time. That was not the kind of hardware that anybody in a traditional IT organization, had any experience with before, right? This is predating the PC, and even, I mean, to some extent, I mean, a lot of our systems kind of were birthed out of the mini computer environment.
They predated
the
Sun
Baxter.
workstations too, for that
They
matter.
did. They did. I mean, very early, they were just starting to emerge, right? But they really hadn't achieved really significant traction in traditional enterprise use. Traditional enterprise was dominated by the mainframe. So as we worked our way through the initial bubble of business that came from the early adopters that were really being driven by the government, we started to run into the, scars on my back sort of IT guys who were saying like, well, how am I going to do this? You're not touching my mainframe, kind of thing. And that was a significant wall to hit. And there was a lot of industrial R&D and people who were willing to kind of work with the newer tools and the newer platforms to do certain things. But over time it became clear, and certainly by 88, 87, 88, 89, the initial wave of enthusiasm had died off because people were looking for something easier and cheaper. And by easier, I mean we were still dominated by the sort of notion of the knowledge engineer as an expert who was going to be the person to come in and know how to use the tools to be able to solve this decision-making problem. The expectation that was that was a very difficult thing to do because people were coming up to speed on a constantly sort of changing and innovating slew of ways of building expert systems, as well as trying to understand how to do the knowledge elicitation task and try to get things pulled together in a way that would then be easy to transfer into an organization. That was a problem that really was difficult to solve. That when you add it to the pressure to try to understand how to translate the technology into a way that mainframe enterprise computing would be able to absorb, a lot of the original companies really sort of hit a wall. The thing that was really interesting in the Inference experience was one of our initial flagship customers, NASA, NASA Johnson Space Center to be precise, because the different centers had their different tool sets that they had kind of championed over time. But they said, look, we want to build these kinds of systems, but we don't want to have this hardware and we don't want to pay your license fees. So they basically reverse engineered the rule language in ART and released their own implementation, as effectively as open source. And at the time, they were a very important customer for us, and we didn't want to, go to battle over that. So we let that happen, really without very much comment, and then ultimately took the code base that system that those folks down at Johnson had built, and then made that into a new version of ART, called that ART IM. So we were able to go to a lower price point to be able to run on more traditional hardware and so forth.
But its functionality was only a subset of the original ART.
Right. So the hypothetical reasoning bit was gone. Other aspects of it were limited. It wasn't the kind of rich interactive environment that you have with list machines and so forth. But it was good enough to build rule-based expert systems and do that reasonably well. And a lot of other people kind of followed the same trajectory. I mean, when Neuron Data came out, the combination of very simple, very focused, beautifully done on the Mac, okay, at a price point that was, several orders of magnitude lower than, the initial stakes of investment for somebody just getting into it in 1984. That was a huge turning point for, the traditional expert systems companies. We all had to go in that direction. So it was, really three things: the difficulty of doing technology transfer into a traditional computing environment, the collapse of the price point, so to speak, and then the remaining challenges in articulating how somebody could use the technology effectively, and getting that into a broader and broader set of people's common programming practice. I mean, that created an environment where in 88 and 89 people were looking around and saying, how are we going to progress the companies? How are we going to grow and build businesses moving forward?
And that wasn't just inferences, that was across the AI companies.
Right, and you know, if you look back at, you know, places like Intelligence and so forth, I mean, those people were starting to get to a place where it wasn't about building a tool and then solving all problems. It was about maybe building a tool, but focusing on a given application and building differentiation there. And, you know, in retrospect, that's a challenge that every software company faces these days. That has become much more professionalized, I would say. You know, the notions of, you know, lean, you know, startup practice and, you know, MVPs and, you know, product market fit. That's all a way of talking about the challenge that we faced there. Was, you know, we come out with an idea, we had a certain amount of success initially, that turned out to be illusory with regard to the really, you know, a really sustainable growing market, and companies were forced to try to understand how to pivot to things where they were delivering solutions that made sense to people. And you know, and that was the challenge that Inference was faced with at all, you know, IntelliCorp, Technology, you know, all that first generation of companies, and some of the later players too, because, you know, a lot of them, although they were building simpler tools that ran on more, you know, on easier to ingest technology stacks, if they had come at it from the perspective of we'll have a general tool and then other people will be able to apply it, they were facing that same kind of challenge.
Yeah, so how, so as you say, everybody was having this problem with the original conception of expert systems technology. How did Inference deal with it?
Inference kind of went into a period of sort of introspection and exploration of different alternatives. And I took it upon myself to try to understand how to tackle the problem from the point of view of how do you make knowledge engineering itself much, much easier? How do you build, you know, expertise into a system without a lot of the things that we had run into? You know, when you listen to the kinds of things that we talk about in the early expert systems days about you interview the expert and you get a bunch of rules and then, you know, you go and do that. Just put it in the engine. You know, that was great for certain very small, narrow things that weren't very complicated. One of the things that we had kind of fallen into the trap of because of our specific technological path was, you know, rule-based production systems. You know, firing off of, you know, activations based on the state of the database and so forth, turned out to be really hard to understand how to control, right? And you would get all sorts of unintended things happening, okay? Which, if you took a much simpler approach to the things that emerged later with machine learning and decision trees and the like, you know, you didn't have to worry about that. But at the time we were going, you know, it requires expertise to understand how to wrangle rules and put it all in. So I wanted to understand how to do that easier and better. And at the time, work that was coming out of, for example, people associated with Roger Schank at Yale, Chris Hammond at the University of Chicago and so forth were really beginning to explore technology called case-based reasoning, which was really more around you just basically describe a problem and its solution, and then you make the problem you're facing something that triggers the retrieval of previously experienced problem-solution pairs and brings a solution to, you know, to the decision maker as a recommendation. Which now, as we look back at it from, you know, this, you know, the perspective of our times, that's a search problem, right? But search engines were not a thing at the time, so that wasn't a natural kind of solution. But what I said was there were two things that were happening. One was that sounds like an intrinsically better way to build a system for helping people make decisions. And we had recognized the fact that there was an opportunity in customer support organizations to help codify that kind of problem-solving knowledge and deliver it to, you know, people at that point, again, pre-web, you know, who were manning telephone banks to be able to answer questions for customers being posed in. So that led to the creation of a product called CBR Express, which was really focused on that. It's like building case bases to help telephone support people initially, and then ultimately people were working on products and services and supporting them in the field. That was the thing that we went off and explored, and that grew. And we started to market that. We brought that out in the 90, 91 timeframe, and that showed real promise. At that point in time, Alex Jacobson had been moved aside by the board, and they had brought Pete Tierney, who was a Oracle veteran, in to helm the company. And Pete was supportive of that. There was a whole part of the company that was still very much wrapped around enhancing and developing the ART expert system shell, which at that point in time had grown into a product called ART Enterprise. But I think that Pete and the board saw the real opportunity as being manifested in the context of delivering these customer support tools on the top of systems like CBR Express. Simultaneously, companies like Clarify and Vantiv up here in the Bay Area had begun to emerge, really focused on the problem of customer relationship management. And this was a significant component of that. And so we kind of began to feel our way through to a use case and an application where the technology wasn't that hard for people to learn how to use, that they can integrate fairly easily, because at this point in time we're starting to work on top of PCs and networks within enterprises that were free of the constraints of the mainframe world. Mm-hmm. And it began to grow, and that was kind of the pivot that Inference began at that time.
Well, that had, as that split evolved, it had implications for the company, it had implications for you too.
Yes.
So how did your own work change over the course of the evolution of CBR Express?
Well, I mean, part of it was kind of, sort of crystallizing the notion, evangelizing it within the company, doing the early work and getting the early version out, helping build the team that brought that to market. And then, beginning to, take a look at this, the other kinds of opportunities that sort of became clear, which were really kind of in this retrieval engine space. Right, but it was not, the company's direction began to kind of diverge from my own personal interests around that time, because, I had been there at this point from 84 to, this was starting to get into 93, 94. There was an interesting period where we launched CBR Express, and it caught the eye of folks up at Microsoft. And we began, and they said, we're not so much interested in CBR Express for our help desk, but we are interested in embedding it into our future operating systems work. And so I spent about a year and a half working very closely with folks up at Redmond in the context of the Cairo operating system project, which was kind of one of the versions of NT that didn't really necessarily come to fruition the way that they had hoped. But a lot of that was involved in trying to say, okay, well, here's a thing that you could bring to bear that would allow you to be able to pose questions and get solutions that you could embed into an operating system, and have that be part of the functionality of what was intended to be the Cairo version of NT.
This is the help system for Cairo, or?
Yes, not so much the help system, but what it ended up morphing into was really an approach to doing information retrieval as part of the operating system. Now, all of that kind of ended up on the cutting room floor, up at Redmond, but there was a long period of time where we were working very, very closely, spending time up in Redmond, engaging with folks like Paul Moritz and Jim Alchin, ultimately having a meeting with Bill in the boardroom and that kind of a thing. And we ended up actually cutting a deal with them for exclusive use of the technology. And that was a big milestone for us, because it was kind of a real validation of what it was we were trying to accomplish, which ultimately led nowhere in terms of what it was they were shipped. But it had a bit of an impact, because I think it opened up the eyes of folks up there in Redmond with regard to retrieval and its use not just for customer support, but as a capability in and of itself in software. And a lot of those ideas were beginning to kind of evolve and formalize at the time. But around 94, we started to see some of the first glimmerings of the web as we came to know and love it. I was very fascinated with hypertext technology, hypermedia technology. I've been following it, but up until that point, until Tim Berners-Lee had the brilliant insight that you don't want to force people to maintain the consistency of linking backwards and forwards. You just let people go and write it and link it and let the network go from there. When the web appeared, it became clear that this is a tremendous way to be able to deliver that kind of decision-making functionality. Alex Jacobson, who had become chairman, was kind of kicking around for something to do, and I began talking to him, and we started talking about, this is a thing we'd like to proceed and do. The main company was either, about to spin out Art Enterprise as its own company, Brightware, and focus on CBR Express, and this was a thing that, essentially, the board gave us a hunting license to go off and explore to see what we would do with next. So that's kind of where I began to, we began to lay a path out of Inference and kind of the next stage of things.
It's a big transition at Inference at the time. As you say, there's the Art Enterprise group split off to a company. CBR Express had its own life. What was life at Inference like? Was it troubled?
By that time we had spent, it's close to, 15 years in business. Had, after the initial boom in the mid '80s, we've gone through a few phases of waxing and waning. Some layoffs, some growth, and so forth. So people were, they were veterans and they had been there a fair piece of time. I think people were still engaged and the like, but it was a much more mature company than it was in the mid '80s and kind of the sorts of boom days. I think people were encouraged by the fact that we had found a thing to pivot to. That had real, opportunity. And the sales organization was being productive in that regard. Pete saw a lot of opportunity there. The sort of the art side of the company was, it's not fair to characterize it as tilting at windmills, but there was a feeling of frustration that they really hadn't kind of broken through with what they saw as the promise of those kinds of technologies and the concepts. But it wasn't. It was an okay environment at that point in time.
Well, you're about ready to start your next company around that time. So with Alex Jacobson, I gather?
Yes.
What was the point of transition? Where did the Inference board decide that it was time for you to leave, or when did you decide?
Well, this was around it was in '94, and we had been having these conversations, and we were pretty open about it, and Pete and the board were fairly supportive, right? They gave us, as I said, kind of a hunting license to go and see if there was an opportunity there. And Alex and I went out and talked to a lot of people, and in the process of talking to people, we ran into Howard Morgan, who at the time was a board member of Quarterdeck, and Quarterdeck had just brought on a CEO by the name of Gaston Bastien, who had come from Philips originally, had been the head of the Newton project at Apple, and had ended up at Quarterdeck, and was really focused on taking Quarterdeck and turning it into a company that was an internet company. Now at the time, the notion of an internet company was something that was relatively undefined, and Quarterdeck thought of internet software as things that you basically sold just like antivirus software, which was you put them in boxes and shrink wrapped, and you had end caps at stores like Fry's and so forth, right? And they were looking for product, and what happened was the things that we were talking about and the concepts that were evolving were around how do you make retrieval better on the web. And at the time, the search engines on the web were things like Web Crawler, Lycos, and the like, which were all interesting, but not operating at the level of capability and scale that ultimately in a few years Google would. And I kind of came up with the idea, well, wouldn't it be great to build a desktop assistant to help you manage your search queries and sort of and repeat them and gather, show you new information and kind of have your sort of search assistant environment. And so we proposed that, and QuarterDeck said we'd love to fund that. And so we did a deal where QuarterDeck put up the money. Inference took a piece of the company that Alex and I founded to do that. QuarterDeck funded it, and we again went off in a 5-month sprint to get, not this time to AAAI show, but to Comdex with a product. And that was the birth of a product that we called Web Compass.
At a company called
Limbex. And it was completely incubated by QuarterDeck. We worked in QuarterDeck's offices. We were working with very closely with the QuarterDeck people in terms of the launch and the packaging and the positioning and marketing. And we took it to Comdex in Vegas. And
who came with you?
Alex from Inference.
Yeah.
It was just me and Alex. And I hired a few folks over the internet of the time.
Really?
Brian Ulysny, who's now at Thomson Reuters, just come out of MIT. Jay Nelson, who's a tremendous software professional working in the LA area. Christina Lerman, who's a professor at USC ISI now. All of us, Linda Rudell Betts, who was a librarian, because I thought that was an important piece of capability. And we all kind of pulled together and built this thing called Web Compass, took it to Comdex, and in just a confluence of weirdness, ended up getting Byte Magazine's Best of Show award, which, at the time I looked back and said, okay, well, who won the Best of Show award in the past? And it was not necessarily a tremendous predictor of future success, but it was a great honor. And it was kind of being of the moment, something different, but of the internet and intriguing. And it had one really interesting kind of ultimate impact, although it was, it ended up kind of not necessarily being in sync with where the internet went and evolved in terms of where that kind of capability of search assistance and alerting sat, whether it was on a server or on the PC and the like. But John, blanking on his name, John Udell, who was a columnist at Byte and was one of the people involved in the decision-making process associated with Word. And I had a conversation. And one of the things I remarked to him was that, one way you could think of building systems on the web was using a concept which, originally had been pioneered by some folks at CMU and out here on the West Coast of remote procedure calls. And so it's like, look, when you make a request of a website, you can view that as a function call, and the results coming back, is the response to the function call, and you can actually build and compose systems that way. So John noted that, and he mentioned that apparently, and I learned about this years later, on a blog post that John had put up. He mentioned that to Tim O'Reilly, and Tim said that's a great idea, and ultimately his whole championing of Web 2.0 was kind of birthed out of that sort of initial insight. So I can't really lay claim to that concept, but it was a first instantiation of how do you build things on the web which compose systems in a way where you're using HTTP calls to be able to kind of glue stuff together. And so Web Compass was fun, but it was very quick. It was like 15 months from start to the point where we had an exit with a purchase from QuarterDeck. Because when we got to Comdex and we won the award, Gaston turned right around and said, we have to own you guys. But that conversation took a long time to come to fruition for the usual sort of reasons around tax events and the like. But ultimately that was very successful. It was very, very quick.
Was there any AI there? I mean, you've been working in AI for so long. Did you bring some with you?
Not so much that system. The one that we did immediately after that, though, did at TriVida, which was once we had the success with QuarterDeck and the exit, kind of Alex and I sort of turned around and said, okay, let's do another one. And that was one where I kind of
Did you
came
consider
back.
yourself a serial entrepreneur by then? I mean, was it part of your consciousness that you were going to be starting companies?
By the time I got through the second one, yes. but at that point in time, it just seemed like the natural thing to do, right? Plenty of ideas. Everybody has them. So that was a system which was really coming back to things that I had learned about machine learning in the 90s, and in particular technologies which today, people would talk about as neural networks, but were basically, single layer, linear, functions are trained, in a way where where they would learn online. So this is out of work by people like Littlestone and Varmuth, and online learning with algorithms like Winnow and so forth, to be precise about that. And so the idea was, let's wrap one of those kinds of engines in a web server, expose an API to that, and then allow people to be able to tackle problems using machine learning. But we had learned the lesson at Inference that we really needed to have an application to kind of go after, and after some initial exploration, what that system did was turned into one of, as I understand it, the first applications that focused on cross-sell, upsell personalization on websites. So we ran these servers that would learn from data that people would provide us by instrumenting their websites with cookies, so we could track user behavior in terms of what pages were being looked at together. We build the models, make the predictions, return those as responses, and integrate that into. And this is all 97, 98 time frame. And had some initial experiences with people like Barnes & Noble and the like. And it was an example of a personalization software as a service very early on. And ended up in an exit in 2001 with a company called BeFree back east.
How many people were you at TriVida?
I think TriVida, we got to about 40 before we exited, and the exit was in February of 2000, which was a propitious moment, because that was the very moment the initial web market peaked, and we got out through the open window with a sash hitting our heels as we got out the other side, and it was a pretty crazy time. And so immediately after that, we were part of BeFree, which was a internet marketing company.
I don't remember them. Where were they out of?
They were out of Framingham, Massachusetts. Sam and Tom Gerace, a pair of brothers, had built that company, and they've since morphed into a number of companies that came out here to the West Coast, really essentially selling affiliate marketing services and the like. So they were kind of assembling a suite of technologies to cover that space. And we were part of that group for a couple of years until the market really began to pinch, and they had to reduce headcount and costs, and they said, we can't have a LA office anymore. And so myself and our technical people were out the door. Went down to Typhoon Restaurant in Santa Monica and had a drink, and I looked around at my best two technical guys, Cormac Toomey and John Jensen, and said, let's do this again. That was the point where I was probably characterizable as a serial entrepreneur, but it was a huge, in retrospect, that was a decision I should have made more prudently.
Why?
Because the third company that I did, Siderean, exploited a lot of what I had been seeing as opportunities from the earlier expert systems days, and this idea of making retrieval better and more effective, and brought in a lot of technology from the semantic web community into building a semantic search platform. And that just was that was the experience that I think many serial entrepreneurs go through, where you think you know what you're doing, but ultimately you find out you were simply luckier than most as opposed to better than most. And that was a very chastening experience. Siderean did a lot of really good work in building that kind of concept, pioneered along with other companies like Endeca, some of the early ideas associated with faceted search and navigation. and did some really early work on customizing what have become standard platforms for search like Solar and so forth. But we struggled to find the right kind of fit for the market, and we ran into a lot of issues associated with again technology transfer and the burden placed on people trying to absorb the technology from kind of the semantic web underpinnings that we used to kind of organize and architect the system. So it was a company that had its run for about 7 years, venture-backed folks in the Los Angeles area, Clearstone Ventures, Red Rock Ventures up here, Cal down south, and ultimately we had to wind that down in 2008 when the recession hit. It was just no more appetite in the investors to kind of continue to kind of grind to try to find an exit with that. So we wound that down, and that was a chastening experience.
I can imagine. So you weren't involved in the winding down of Inference.
No, I was. By that time I had moved on, and they were acquired in 2000 by eGain, which was another company in that customer relationship management space. But by that point in time, I had moved on long since.
So this must have been a kind of traumatic personal experience to go through.
Yes.
After having such success with a couple of startups.
Yes, and when you get when that kind of hubris hits you, and you really are kind of that invested, and it's 7 years is a long time. It's hard to walk away, and there's also, I think, people have discussed this more broadly. There is a responsibility that, as a founder, you feel to your investors to stay the course, and the people who do that really well know when to say, okay, that's it. But a lot of people feel the pressure to say, well, we're just going to continue to go through until you can't do that any further, and that's the difference between soft landings and hard landings. And the shutdown in 2008 was not a soft landing by any means, and of course that wasn't a period in time when a lot of people where everyone else was having a fine time of it. It was a very challenging environment for everybody, right? But no, it was a significant lesson.
It was a hard landing, even though the company eventually got sold?
Yes, because that was a sale of assets, and that happened a long time after everything had kind of disbanded. So I regret that, but it did. There were some interesting things that we did at Siderean that people have been bringing forward in other applications and in other ways from different sources, and this notion of how to exploit knowledge to make search that much more effective, I think, is one that is still a problem that people are going to gain real benefit from working. Everyone has become accustomed to the traditional type it into the search engine, type 3 or 4 words in the search engine box and get a bunch of results back and kind of weed through that. I mean, Google and its like have made that a universal global experience. But people still struggle in many, many different cases when it's an answer they're looking for that they need to be able to take an effective decision and an action. And that's something that harkens back to the expert systems days, which was about tell me what I need to do in this situation based on your expertise. At a certain point, discovery towards the purpose of making an effective decision there's a lot of overlap there. So what we did at Limbex, some of the earlier systems at Inference, what we're trying to do at Siderean shares that kind of common theme. How do you wrangle information to get it in the right place at the right time for somebody to know what it is they need to do?
I'm sure that's part of your current life too, but I thought I might ask you, as you're now in your life about to transition to a big company, how you feel about your entrepreneurial days. Is there another startup in your future?
I don't know. It's something that I think about not every day, but quite often. It is I do know based on experience how difficult that is, and the responsibility one has as a founder. Okay, if I were in a position for somebody to trust me with that responsibility again, I would welcome that. But I know the costs. And, as one goes on in one's career and one's life, it's a significant question about whether those costs are worth incurring for not just your, quality of life, but the quality of life of everyone else you're involved with and your family and friends and so forth. And so, it's not a decision, going in that direction again is not a decision you would take lightly. And, it's a very difficult thing to do when your risk-reward trade-offs are set to a different place than they were in your 20s or 30s or even 40s, right? So, but the thrill of the chase, the thrill of taking a raw idea and shaping it and positioning it and bringing it to market and evangelizing it and getting traction and seeing people get benefit from it, that's a tremendous thing. And, you can do that in a large organization as well. But the romance that many people bought into with regard to doing that as a startup is always something that's a siren call that beckons.
Speaking of romance, you've now been in LA almost your whole life.
Yes.
Do you still love LA?
I do. It's a tremendous city. And, over the time that I've been there, I think it has blossomed and matured in ways that, when in the early years that I was there, it could have its rough edges, right? I mean, we went through some challenging times with the riots and so forth. And I live in a community that is privileged relative to the entire LA basin, but I can drive 5 minutes and be in a different place along those lines. And that's true of many urban environments, but the tapestry of cultures and cultural experiences and so forth in LA is just tremendous. And the beach isn't bad either. Yeah. And I've enjoyed it, and it's been wonderful to see Los Angeles kind of have a renaissance, if you will, with technology as a vital sector. It's always going to be an entertainment town, but what's happened with Silicon Beach and the like. I've been involved with one of the incubators down there, Amplify. I've done mentoring of a number of and advising to a number of startups in that environment, and so it's been gratifying to see that kind of part of my life get more of a footprint in LA, but LA in general has just been a tremendous place to live. I'm very happy there.
So after being a serial entrepreneur, what were you thinking that led you to take a job at a staid publishing company like Elsevier?
Well, the salary was one. Money was an important thing. But what was interesting was that Elsevier had been a prospect at Siderean. I had spent a lot of time with with executives there, understood their problems and their challenges. And when I wound down the company, after a brief stint working with folks at Symantec, they reached out to me and they said, Brad, we could really use your skills and experience in-house to try to affect some of the stuff that we're trying to drive forward here. And I said, okay, I'll try that. They gave me a tremendous opportunity to remain in LA, which was important to me from a family perspective at that point. And came in to the Elsevier Labs group at the time, and shortly thereafter the head of Elsevier Labs came to me and said, I'm going to be moving on myself. I'd love you to take the position. And so I assumed that responsibility within the group. And then a number of years later, Dan Ollie came in to be CTO, and he said, I want you to kind of step up and be chief architect and help me kind of wrangle the things that we need to wrangle to get the company where it needs to be as a technology firm.
Can you tell us a little bit about that, about what you are actually doing there? I don't want to get into anything.
No, it's the thing that is really, really interesting is, there's a lot going on with scientific publishing and what researchers are trying to do in terms of the future of research communications. There's a lot of controversy in terms of the ecosystem and the economics associated with it. Elsevier has a role that goes back 140 years. So we're talking about a company that is probably, at least 2 sigma out from the normal lifespan of a company. I mean, this is a company that's been around a long time. There's a lot of tradition. That, not long before I got there, it was really effectively a manufacturing company. It would commission publications. It would, go through the process of putting those things into the kind of beautiful shape that they can sit on library shelves on. They would print them out, put them between pieces of cardboard, and ship them off to, your university library. The transition that the web represents for organizations, not just traditional manufacturing organizations, but traditional media companies, has been a tremendous challenge. And the company, before I got there, had already negotiated sort of the first step of that transition from, being a print publisher to being an online publisher, and had done so, very successfully, to the point where they had managed to do so without really changing their business model. The sorts of things in the long term that are an impact of the web and the way in which information can be replicated and transmitted and so forth, how scientists are beginning to want to work, are things the company is going to need to adapt to. And in the time that I've been there, I've been privileged to be part of the group of people who has, together with the rest of our senior management team, brought forth the consciousness that that kind of change is the thing that needs to be pervasive throughout the company, and that the transition from a traditional publisher into a provider of information solutions, and principally ones that are based on the data of science and healthcare. That's been a huge culture change and a huge change in perspective that didn't exist when I started there. And so participating in that has been really an interesting thing. The whole thing about having an immensely successful company that needs to change course, and figuring out how to do that without destroying the company in the process it's kind of the thing that we honor and idolize in Silicon Valley is the startup story, right? But there's this other story about how do you take a tremendous legacy asset like a company of that sort and change it in a way where it can survive to profit another 140 years. That's been an interesting process to be part of.
Hard problem.
Yeah.
They're more failures than successes with those kinds of problems.
As there are with startups.
Yeah.
But it's been fascinating and very illuminating, and it's an organization that is orders of magnitude larger than the ones that I was dealing with as an entrepreneur, and before that working at Inference and at CMU, and that's been it's been a fun learning curve. A learning curve I probably should have gone through a little bit earlier in my career, but one that I've enjoyed nonetheless.
Good. It's a big switch, big challenge, I should think.
Yeah.
So as we're starting to wrap up, I want to try to draw some themes. Where's AI in your life now?
AI is something I deal with, investing in, evangelizing, and understanding how to use effectively every day. As chief architect, a lot of the things I'm working on are about building the data and knowledge underpinnings into the company so that it can build the class of applications that can leverage that sort of technology to provide value to our customers, helping them make decisions either as researchers or medical professionals or nursing students, which is another constituency for us. And I'm responsible not just for the enterprise architecture function, but for the labs team still. And we've brought folks into the labs team, Ron Daniel, Paul Groth, who I've known, in previous, incarnations, who have a lot of roots in the semantic web community and standards, and together we've been working on with an increasingly, growing group of data scientists and natural language processing professionals and semantic web experts that we've been bringing into the company to build that platform and to build the technology capability to realize the sort of promise of those technologies. So it's very much front and center for not only myself, but the company and senior management as a whole, because we see that as part and parcel of how we are going to be delivering value in the future.
I thought I'd ask how you felt about the AI renaissance that we are in the middle of. You've been in this for a long time. You've seen a lot of different aspects of AI technology. What's going on with AI? It's all over the front page these days.
Yeah, and part of it is is amusing to the extent that you see the same sorts of things happening that we saw back in the mid '80s of abusive terminology and astronomical expectations with regard to the capability of systems or the like. But and some themes that are parallel are really actually pretty amusing. As the challenging rising nation state, we have China as opposed to Japan. We have outrageous starting salaries for young researchers in industry. Yet again, we have specialized hardware, that people have to figure out how to integrate. But there are really significant differences, and I think first and foremost the impact of a globally networked community of software practitioners and information sharers has just been amazing. I mean, in the context of Elsevier, just looking at the rate at which ideas are explored, disseminated, and acted on and replicated is, it's just amazing how quickly that's happening now. Where I can open up something that somebody has just put up on, a preprint service and go to GitHub and get the code and work with it hands-on and do that on a weekly basis, that has, I think, put a much larger group of people in a position to work with the technology, deliver it, and build it into systems in a way that we just had no ability to do back in the 80s, right? So that's a huge difference, and I feel that I'm personally taking advantage of that. So it feels like a rebirth in a personal way as much as from the point of view of the industry or the community as a whole, because it feels like once again I'm participating in that chain of progression from the early ambitions of the pioneers of the 50s to what it is we're realizing. I had this experience a few years back. I went to the ACM had the 100th anniversary of Turing's birth, and it was co-located with the Turing Award for that year, which was won by Judah Pearl for his work on probabilistic graphical models. And they had assembled as many of the Turing Award winners as they could muster, and had a number of different panels. And they had one panel that had folks like Raj Reddy and Ed, I think, who was there, and other people up there and talking about all this has been accomplished. And take Raj for example. Raj was there in 71, 72 with speech understanding and recognition. And that work followed through in a continuous chain of development to the systems that we have now. Realizing, that kind of speech recognition capability on phones, independent, speaker independent, all of that, right? That was the thing that he had in mind. It took 40 years to deliver that, right? And so they're up there kind of like this exhausted but like mildly pleased look on their faces, like, yeah, it actually happened, right? And I think that some of the promise and some of the ambition we have is still going to take decades to get through. But we're getting real practical results out of real work that's been done in these areas of deep learning and trying to build systems on top of that those sorts of algorithms that are leveraging not only the stuff that came out of the past, the work in symbolic AI and so forth, but are pointing new ways to be able to build more and more capable systems. And so it feels great that I still am in a position to be able to leverage and work on those kinds of applications in a more traditional corporate context now, but in an area where that is just as important to the company's success as it was when I was trying to do that sort of thing in a startup. And so I think a lot of this work that's going on right now is great. A lot of it will still hit the same sorts of walls. Okay, there's only so much you can do with perception in terms of exhibiting real human judgment, right? I think a lot of the insight from folks like Rod Brooks, which created a huge revolution in building really effective robotic systems, right? Needs to be brought into and applied to the kinds of decision support systems that we're building, which will allow us to get through some barriers, but we'll still run into the sorts of things where people wanted things that were really about people-level decision-making that we're just really not going to be able to capture with machines. And so in the end, I think, the old debate between artificial intelligence or intelligence augmentation is a valid one. If you pressed me on it, I would have to say that, I'm with the intelligence augmentation crew, because the thing that will really transform and continue to transform civilization is going to be, the partnership of people and machines working together in ways that each of them is doing what they do best, as opposed to, general artificial intelligence as a goal per se. But it's a great time, and it's been fun to watch, and I feel, that in my own small way, I'm still participating in that kind of movement.
It is an exciting time. What are your expectations about things you're going to see in the next decade that, from where you sit, seem like really, really important?
A lot of the time, particularly as it relates to Elsevier, has been thinking about how is science transformed, right? And one thing I think that's certainly the case is things that have really taken off and grown wildly as a result of the introduction of computer technology has really been around communications, right? So really changing how science is done in a way which leverages, in a real sense, what's happening with communication, as opposed to trying to replicate the paper-based way in which we did that. I think that's going to come down to a situation where you'll be able to have people start real experimental programs in the hard sciences, the way that software entrepreneurs up here start software companies. They'll sit down in a cafe somewhere, they'll get on the local Wi-Fi and they'll bring up some services and they'll say, I want to do this and this and this and this and this. And it will invoke a whole range of services that, are, either front ends for contract research organizations, or automated laboratory test equipment, that kind of a thing. Go off, do that, bring all the hypotheses, all the experimental results back, do some initial organization and automation and so forth, and allow people to do laboratory work without going through the considerable effort, both in terms of the process of becoming a blooded researcher in a university, as well as just the sheer labor involved in putting something together, leverage and that sort of thing, and sort of accelerating science and having the machine, in the ways that were pointed to by Doug Lennett's AM system or Pat Langley's, work on, automating discovery, where the machine becomes a partner in that process, sort of a virtual marching robot army of lab assistants that would empower scientists in trying to drive those sorts of things forward. So so much is bound up about how we manage to continue the progress associated with science and technology and research in what will be undoubtedly, in my mind, a much more challenging environment. Challenges like climate change, the geopolitical environment and so forth. It's going to be rough to continue a lot of the progress that we've seen, over the past decades, unless we're able to figure out how to do it leveraging these kinds of tools that we have. And that kind of goes to this point I was making earlier about intelligence augmentation. It's about getting people in a better position to be able to communicate effectively, not only between themselves, but with machines to do things that they simply wouldn't be able to do individually or do very easily.
Well, I've got more questions, but I think that's a good place to stop. I think we've covered a lot of ground. Fascinating stuff. As you were speaking just now, I realized there's still stuff from back in your CMU days that has never really been applied. and that will, AI ideas that will probably find their way into future products and economies. But it's really amazing how much of the work that you did back then has just mapped right into things that the world needed.
I'd like to think so. And I mean, a lot of people have, I mean, these ideas are cheap in a certain sense. A lot of people have them. The good ones keep coming back, no matter who's involved. And so, it's been fun from that perspective. Trying to wrangle these things from back then into results today.
Good. Well, thank you very much. This was a pleasure, and I'm sure a lot of people will enjoy this video.
Thank you.